have you ever really wondered what's happening inside a firearm when you pull the trigger? I mean, it's this incredible world of springs, levers, and yeah, controlled explosions. And from a mechanical standpoint, it's absolutely fascinating. So today, we're going to strip away all the jargon and take a look at the core engineering of how these machines really work. And you know what? That confusion is exactly why we're doing this. The source material for this explainer points out that a lot of the terms we hear all the time are, well, often misunderstood or just flat out used incorrectly. Our goal here is to bring a little clarity by looking straight at the mechanics. So let's just start with the absolute basics. Is a revolver a type of pistol? Is semi-automatic the same thing as automatic? These are the kinds of questions at the very heart of all the confusion, but the answers are actually pretty simple once you see how everything is classified. Okay, now here's where things get interesting right off the bat. It all depends on where you are. In classic English terminology, pistol is just the big umbrella term for any handgun. So a revolver? That's just a revolving pistol. Simple enough. But in the US, a pistol and a revolver are seen as two totally separate things. For the rest of this explainer, we're going to stick with the American usage, just because it's what you see most often in movies and online. So let's dive into that first major category, handguns. We're going to break down the two main types we just talked about, the classic revolver and what most people today just call a pistol, or a self-loading pistol. But before we can see how they work, we got to meet the two most important players in pretty much any trigger mechanism, the bent and the sear. Just think of the bent as a little hook or a notch on the hammer, and the sear is the latch that catches onto that hook. All the magic really happens the moment the trigger tells that sear to let go of the bent. Okay, so to really understand everything that comes next, we have to start right here. This is square one, the simplest, most fundamental design out there, the single-action revolver. This is your classic cowboy gun, and how it works is just beautifully straightforward. Think of it like a two-step dance. First, you, the user, have to physically pull the hammer back with your thumb. That one action, cocking the hammer, does something else at the same time. It rotates the cylinder to bring a fresh round into position. Then, and only then, can you pull the trigger. And that trigger pull does just one job: release the hammer. Bam! Two separate actions for one shot. And this is where you can really see the evolution of the whole mechanism. The double-action revolver was the big upgrade. Instead of those two separate steps, one long, smooth pull of the trigger does the whole shebang. It rotates the cylinder, it cocks the hammer back, and then it lets it go. It combines both of those actions into one single pull. Pretty clever, right? Okay, now we're about to make a huge leap forward. Self-loading pistols, or what people usually just call semi-automatics, are a totally different beast. They do something ingenious. They actually harness the energy, the literal backward push from the fired bullet, to automatically kick out the empty casing and load the next round from the magazine. So you might be thinking, what stops one of these from just firing over and over like a machine gun? Well, it's this little piece of brilliant engineering right here, the disconnector. As soon as a shot is fired and the slide moves back, it disconnects the trigger from the firing mechanism. You have to physically let the trigger go forward again before it can re-engage to fire another shot. It's the part that enforces one shot per one pull. All right, we've covered handguns pretty well, so let's shift gears and move up to the long guns. Now, the principles are kind of similar, but the actions and what they're used for are pretty different. We're talking about rifles and shotguns. You know, one of the most iconic and mechanically simple rifle designs has to be the bolt action. There's no fancy gas system, no recoil operation. It is completely dependent on the shooter manually working that bolt for every single shot. And because it's so simple, it's famous for being incredibly reliable and accurate. And the operation is this really distinct three-step process. First, you push the bolt forward, which grabs a new round and shoves it into the chamber. Then, you turn the handle down, which rotates these little locking lugs into place and seals everything up tight. And finally, you pull the trigger. To fire again, you just do that whole process in reverse and then forward again. And then we have another classic manual design, one you've definitely seen in movies, especially with shotguns, the pump action. You might also hear it called a slide action. Instead of that turning bolt, you just use a sliding grip under the barrel to kick out the old shell and load in a new one. And hey, while we're on the topic of shotguns, it's worth checking out all the different ways they can be set up. You've got the common over and under and side-by-side barrels, but in Europe, you find these really wild combination guns, like a Zwilling, which has one shotgun barrel and one rifle barrel, or even a drilling, which has 3 barrels in all sorts of crazy combinations. All right, now for the big one, the word that causes more arguments and confusion than any other: automatic. Let's break down exactly what that means from a mechanical standpoint and how a firearm can actually achieve continuous fire. So let's just get this straight once and for all. Here is the technical definition. A firearm is only truly automatic if you can hold the trigger down and it will keep firing one round after another until you either let go or it runs out of ammo. It doesn't have that disconnector we talked about earlier. So how does that even work? Well, the most basic way is a system called simple blowback. You saw this in a lot of early submachine guns. And honestly, it's just pure physics. There's no real lock. It just uses a really heavy bolt and a really stiff spring. The sheer inertia, the stubbornness of that heavy bolt to get moving, is just enough to keep everything sealed for the split second the bullet needs to leave the barrel. Then the pressure blows the bolt back, cycling the whole action. Simple, but it works great for less powerful cartridges. And that brings us to another key distinction, and this chart lays it out perfectly: the difference between a submachine gun and an assault rifle. It really boils down to the ammo. SMGs shoot lower-powered pistol bullets, which means that simple blowback system can handle them. Assault rifles, on the other hand, fire a much more powerful intermediate rifle cartridge, and for that, you're going to need a much stronger system. Yeah, because that rifle cartridge is so much more powerful, an assault rifle just can't use simple blowback. The pressure is way too high. It would blow the action open way too fast. So instead, they need more complex, locked systems. Many use what's called gas operation, where they siphon off a tiny bit of gas from behind the bullet to push a piston that works the action. Others use these incredibly intricate roller locking systems. But either way, the goal is the same: keep that breech locked up tight until the pressure drops to a safe level. Okay, for our last section, let's go all the way to the end of the line, to the muzzle of the barrel. Now, these attachments aren't really part of the core firing mechanism, but they can dramatically change how a firearm performs. Believe it or not, what you screw onto the very end of the barrel can totally change how a firearm behaves. Our source material breaks it down into 6 primary types, and each one has a very specific job to do. Okay, let's run through them real quick. First up, you've got sound suppressors, which use a bunch of little walls inside to slow down the gas and quiet the shot. Then there are recoil reducers, or muzzle brakes, which vent gas up or to the side to fight against that kick. Flash hiders do exactly what they say. They break up that big ball of fire at the muzzle so you're not blinded, especially at night. You might see muzzle counterweights in competitions, just adding weight to the front for stability. Of course, there are grenade dischargers for military use. And get this, some machine guns use recoil boosters, which actually trap gas at the muzzle to help push the barrel back and make the whole system cycle even faster. So we've gone on this whole journey, right? From the simple click-clack of a single-action revolver all the way to the complex, gas-powered systems of a modern rifle. Every single step along the way was some fascinating solution to a really tough mechanical problem. So it kind of makes you wonder, from that simple little sear holding back a hammer to those intricate roller-locking bolts, which one of these engineering leaps do you think is the most ingenious? It's something to think about. Thanks for watching.